GATE 2017 Civil Engineering Set 1 Question 43. A column is subjected to a load through a bracket as shown in the figure. The resultant force in the bolt 1 needs to be found in kilonewton and rounded up to 1 decimal place. The relevant NPTEL reference has been listed. So if we are given an eccentric connection where a load has been applied at a distance of E from the center, on each bolt two forces act. The first force is an axial shear force, which is equal to P divided by the number of bolts in the connection. So in this case we can see that there are 8 bolts, so on each bolt a force of P by 8 would act in the vertically downward direction. The second force that acts on the bolts is a force due to the moment. This is equal to P into E times R divided by summation Ri square. Here P is the load that has been applied, E is the distance of the load from the center, R is the distance of the bolt from the center, and summation of Ri square is the sum of squares of the distance of all the bolts from the center. Once this has been computed, Fm is found. If we need to find the resultant force, it is given by the square root of Fa square plus Fm square plus 2 into Fa times Fm into cos of theta, where theta is the angle between Fa and Fm. Here Fa would act in the vertically downward direction and Fm always acts in the direction perpendicular to the line joining the bolt and the center of the connection. So for this bolt it would act in this direction. For this bolt it acts in this direction. It always acts in the direction of the moment. So here we can see that the moment is in this direction, which is equal to Pe. So the forces also assist in the same direction of the moment. Here we have been given the value of P as 10 kilonewton and the value of E is given as 15 centimeter. The dimensions of the connection are given and the resultant force needs to be found in bolt 1. So firstly we will calculate the axial shear, which will be equal to P by N. Here P is given as 10 kilonewton and N will be the number of bolts, that is 4. So Fa will be found out as 2.5 kilonewton. Next we need to find the force due to the moment. So that is equal to P into E into R divided by summation Ri square. Here P is 10 kilonewton, E is given as 15 centimeter and R is the distance of bolt 1 from the center. So here we can see that this dimension is given as 10 centimeter. So this whole distance would be 10 centimeters. So up to the center it would be 5 centimeter from bolt 1. So R would be 5. And now we need to find the distance of each bolt from the center. So each bolt, due to the symmetry, would be at a distance of 5 centimeter from the center. So it would be 4 times 5 square. This value would turn out to be 30 over 4, that is 7.5 kilonewtons. Now we need to find the resultant force. So if we can see, on bolt 1 the axial force would act in the vertically downward direction, that will be the same as P. The force due to moment would act in the same direction as the moment. So this would be along this direction. So that would be 90 degrees from the center line, and if we compare it with Fa, so it will be a total angle of 135 degrees between Fa and Fm. So the resultant would be the square root of Fa square plus Fm square plus 2 into Fa into Fm into cos of theta. So here substituting the values we would get 2.5 square plus 7.5 square plus 2 into 2.5 into 7.5 into cos of 135 degrees. This value would finally turn out to be 35.98, which would come out to be 5.99. Since the question instructs to round it off to one decimal place, this can be rounded off to 6 kilonewtons. That will be the resultant force in bolt 1. So the resultant force in bolt 1 was found out to be 6 kilonewton. The relevant NPTEL reference has been listed.